Hi, this is Mr. Denny. I'm going to explain to you how to add and subtract fractions along with mixed numbers. I'll present my screen now. Okay. Last time we talked about how fractions, the bottom number of a fraction often represents the number of parts you need to make a whole. Okay, and the top number represents the parts you have or don't have, kind of depending on what you're looking at. This bottom part's really key to understanding, though, all about fractions. Okay, number of parts you need to make a whole. That's it. That's what the bottom number tells us. All right, I have a few situations here that I want you to model, or that we will model with fractions. All right. Let's say I have 3 Starbursts that I ate from a package of 12, and my friend, he's got 4 Starbursts from their package of 12. All right. We decide we want to combine our Starbursts, and we're curious how much of a whole package we will have if we do so. How can I write that as a fraction problem? And then we're going to talk about which numbers did I add and which did I leave the same. Okay, so if I have a fraction and a package of Starbursts, I gave you how much the whole was, okay? I needed 12 parts to make a whole. So there goes my 12 down here at the bottom. And me, I have 3 left for my package. So 3 is going to go up top. Right, my friend is the same size package as I do. There's still 12 to make a whole. Okay. And he has 4 left. What am I going to do with these two? Well, combine. That's a keyword for adding. Also, I told you down here which numbers do I add. So we're going to add. When I add these two, I'm asking myself how much of a whole package do I have left. So I'm still talking about 12 pieces, 12 parts to make a whole. And what I got left to do? Well, I've got this 3 and the 4 I've got to add. Right, so I have 7 parts. All right. To make, if I'm considering how much of a package I have left, if I combine the two, and that's a little over half. All right. So what did I do? Well, I added that. Added the top numbers, and we're going to start calling them numerators, because that's the official math term we're supposed to use. Okay, I added the top numbers, and I kept the bottom number, and that's called the denominator, the same. And that's how you add and subtract fractions. You add the top numbers, the numerators, you keep the denominator the same. So subtraction, similar process, but let's look at a problem. How would the math problem look if I started with a full package of Starbursts, but then ate 7 of them? How much would I have left? Write the math problem with the fractions down here. Okay. So again, my package is still 12 parts to make a whole. And I started out with a whole package, so I better have 12 parts, right? That's my whole there. I'm going to take away, because I ate 7 of them. Leaves me with how many? All right, I'm still considering the whole package is 12, so I still need 12 parts to make a whole package, and I'm going to be left with 5 of those Starbursts. Okay. What parts of the fraction did I subtract? Which I'd leave the same. Again, just like addition, I subtracted the numerators, and I left the denominator the same. All right, next problem. Consider if you have 2 mini-sized candy bars. I don't know why I was on a sugar binge here, but I have 2 mini-sized candy bars and half of a king-sized bar. 4 mini-sized candy bars make up 1 king-sized. How much of a king-sized candy bar do I have altogether? Write the problem and answer with fractions. So I'm actually going to start with the answer on this, okay? I'm asking myself, how much of a king-size candy bar do I have? Okay, if a king-size candy bar I'm looking at here, what's the bottom number going to be? All right. Well, we have some mini-sized ones, so maybe that'll give you a clue. And we have a conversion right here. 4 mini-sized candy bars make up 1 king-size. So if I want to think in terms of the mini candy bars, how many there are in a king-size, I can say there's 4. Right? All right. Now, how many of these do I actually have? How many mini-size do I have? Well, I have 2. Okay. And then I say I also have a half of a king-size bar. Well, that's easy because they already give you what the fraction should be. 1/2. And then we're going to say, hey, how much does this equal in terms of a king-size bar? Now we got a little bit of an issue here. We don't have the same number on the denominator like we did up here, right? 12 and 12, 12 and 12. And that is a little bit of an issue. You have to deal with that first before you can add or subtract. Okay? How we deal with it, we find a common denominator. Okay? And how we find a common denominator is we skip count. Okay? Or you find multiples of each of the numbers. I'm going to skip count with 4s right here. And I'm going to skip count with 2s. Really, I don't have to go very far with skip counting because I notice that the first time I have a number in common is with the 4. So that can be my common denominator. And in fact, it's my least common denominator. And that makes sense to use the smallest one. Okay, it helps us with keeping the problem simple. So in other words, I have to find the other name for half, okay, that has a 4 in the bottom number, in the denominator. Okay, now we've talked about this before as far as tape measure fractions. Okay, you might already have them memorized, what 1/2 is, what its equivalent fraction is with the 4 on the bottom. But I'm going to show you a long way to do it anyway, in case you don't. Okay. So 1/2, we want to change this one to where it's a 4 in the denominator. Okay, we want to find the other name for the quantity or value of 1/2, but the 4 is on the bottom. The A4 is on the bottom. All right, so how I work with that is I'm going to go down here to the bottom, and I'm going to multiply that 2 by something so that I get a fraction with a 4 on the bottom. Okay. What do I got to multiply 2 by to get the 4? Well, hopefully you recognize multiply by 2. Now, in order to get the equivalent fraction to 1/2 and to not change the actual value of that, what it's representing, I need to do the exact same thing to the top. I need to also multiply by 2 here. Okay. 1 times 2 is 2. All right. And it is true that 2/4 is the same thing as 1/2. It's just a different name. It's kind of like the reverse of simplification. We're like expanding the fraction. Okay. All right. Now I've changed this 1/2 to where there's a 4 on the bottom, so I can actually do my addition now. I can go with 2/4, and I can add another 2/4 because we changed that 1/2 into 2/4. We got the same number on bottom, so we're good to go. All we have to do is add the top numbers, the numerators, and I get 4 over 4. Now that can be simplified to simply 1, and in this case, we're talking about a king-sized candy bar. So if you have a fraction, addition, and subtraction problem that have different denominators, you need to first find the common denominator and change the fraction so that you can do your addition and subtraction. All right, I'm going to skip this first example. I'm actually going to skip down to the bottom one here, or the second one. All right, subtraction. And we have a different denominator. Okay, so what I'm going to do is I'm going to skip count. Again, if you can see this already, that's fine. You might not need to skip count. I'm going to skip count a few of with the number 16. 16, 32. Okay. Now, I figure out which one's the smallest number that they share, and they both share 16. That's good because I don't have to change this fraction at all. It's already got a 16. This one, though, I've got to change to its equivalent fraction with a 16 as a denominator. Okay, so 7/8. I'm going to rewrite this, make it a little bigger. I got to times this guy by some number here. on bottom so that I get 16. 8 times 2 is 16. And I can do the same thing. I have to do the same thing up top so I don't change the actual value of the fraction. And I'm going to end up with 14/16. Also, as a side note, notice that when we multiply fractions, okay, we actually multiply the top and we multiply the bottom. Whereas in adding and subtracting, once we get the bottom number the same, we don't do anything with it. We just keep it there. Okay. All right, now do not reduce this, okay, even though you might be tempted to. The whole point of this was to expand it, the fraction, so that it would have a 16 on the bottom. If you reduce it, you'll just go back down to 7/8. All right. So now I can actually do my addition here, or subtraction in this case. I can take 14/16 and I can subtract the 3/16. Oh yeah, now I got this. And what do I end up with? 14 minus 3 is 11. And good, I cannot change that at all. Okay, or I do not need to reduce or simplify that. So my answer is 11/16 and my common denominator was 16. All right, let's do one more here. 9 and 6. All right, so you might already know again what the common denominator will be, but I'm going to skip count just to find it. 27, 36, and we'll go with 45. Okay, and then count by sixes. All right, and it looks like the first one that they match up with is 18. Okay. So I'm going to use 18 as my common denominator, and in this case, we actually have to change both fractions, okay, because neither one of them are 18. That's okay, it won't take us that much longer. So if we have the fraction 4/9, I have to multiply that bottom number by something that will give me 18. Well, it's going to be 2. So multiply the top and the bottom by 2 because we got to do it to both. I end up with 8/18. All right, we change this fraction. Now we got to do the 5/6. 5/6. All right, what do we got to multiply the bottom by to get to 18? In this case, we have to multiply it by 3. What do we do the top? We got to do the bottom. Or what do we do the bottom? We got to do the top. And that equals fraction 5 times 3 is 15/18. Now we can actually do our addition here. We can take 8/18. We can add it. 15/18. We end up with the fraction 23/18. Now you do simplify at the end here. All right, I have a number greater than 1, sometimes called an improper fraction. All right, that means that I have a hole in here, okay, because I can take 18 of these 23 parts and I can make one whole. If I take 18 away from the 23 to make a whole, I'm left with 5 of those parts. So the answer is 1 5/8. Okay, last is a problem that we have with a mixed number. How do we deal with mixed numbers when we're adding and subtracting fractions? There's really 2 methods to work with this. The second of which I prefer, but it requires, in order to make it more efficient, a little more mental math. The first method I show you with is we're going to change this mixed number into a improper fraction. So if you recall, this number on the fraction tells us how many parts we need to make a whole. This tells us how many parts we have, and this tells us how many holes we have. So if each one of these holes, okay, has 2 parts, that means we have 4 parts that make up all of our holes here. And then we have an extra here, okay? So we actually have a total of 5 parts total, and 2, our direction is that 2 of them will make a whole. Okay, let's double check ourselves here. if I look at 5, I can take away 2 twice to make my 2 wholes, and I'm going to be left with a single 1. Okay, so the shortcut way to think about this is you take the denominator, you multiply it by the whole number, and then you add the numerator to get how many parts total you have. Okay, so I change this mixed number into an improper fraction, and then I can do my normal, what the process I talked about just a few minutes ago. Okay. And then we're going to have to change one of these into a 4, okay, because 2 can go into 4. So I can change this fraction, do it a little quicker now. This fraction can actually go into an equivalent fraction where 4 is on the bottom. To do that, I have to multiply it by 2. So I have to multiply the 5 by 2. So what I'm going to end up with then, over 2, over 4, sorry, and I'm subtracting 2 over 4. That gives me 7/4. All right, which again, I have a hole here because this is a number is bigger on top. I have one hole. If I take 4 of these parts away to make a hole, I'm left with 3 of them. Answer is 1 3/4. And that method is changing the mixed number to a improper fraction. All right, second method is utilizing the fact that 2.5 2 1/2 is the same thing as 2 plus 1/2. Okay. Also utilizing that 3/4, or the fact that 3/4 is the same thing as 0 plus 3/4. So second method is to work with the wholes and parts separately. This only works for adding and subtracting, by the way. Multiplying, dividing, it gets a little more complicated. You want to stick with this improper fraction method. Okay? All right, now if I know these two facts, then I can work with these things separately. So I'm subtracting 2.5 minus 3/4. So if I subtract the wholes first, 2 minus 0, okay, I end up with, I'm going to move this down so you can see everything. I end up with 2 wholes. Okay. Now if I subtract 1/2 minus 3/4, and I better write that one out. I have to change it to where they have a common denominator. And I know that 1/2 is the same thing as 2/4, so that would be my quickest bet here. To go to 2/4 minus 3/4. Okay. And this, actually, if we have a smaller number, we're taking away from a larger number, or we have a smaller number, we're taking away a larger number, we're going to end up with a negative. Okay, so I'm going to end up with negative 1/4. All right, now that's okay, all right, because we actually have 2 wholes still, positive wholes. So we can take this negative 1/4 and you can take care of it using these wholes here. In other words, I can take one of my wholes, okay, and I can add negative 1/4 to it. Right, what that gives me is a positive 3/4, okay? And then I'm left with, because I used one of these wholes to take care of this negative number, okay, I'm left with 1 and 3/4, okay? Now, this is quite a few steps, okay? Arguably, probably even more steps than this one, all right? But the advantage of this is sometimes it's easier to think if you're able to do mental math in your head, okay, to separate this out. Like I could have done this in my head and gotten to the answer a lot quicker than trying to do this improper fraction stuff, okay? Either way works, all right? You can choose which way you like, but those are the lesson, or the the notes for adding and subtracting fractions, including mixed numbers.